Okay, so here's some little guidance on the notes for a slope using similar right triangles. And we'll put this in your math notebook. So there are three parts of a right triangle, right? There's the vertical line, which goes up and down. There's a horizontal leg that goes horizontally. And then there's the long side that's called the hypotenuse. Sorry, it's really messy. But either way, to find the length of the hypotenuse, you have to use the endpoints. So let's say this is, and for this example, is point A, this is point C, and the point A is at 0, 0, and point C is at 2, 3. That is not how it would actually look on the graph. I'm just giving you an example. And then the vertical leg right here, all you do is take the difference of this point and this point. So what it's saying is that here it was 0, here it was 3, so I went up 3 lines, and that's how tall that horizontal leg is, or vertical leg, excuse me. Then for the horizontal leg, it's saying that this one is 0 and this one is 2, and I moved 2 spaces, so the length of that one is 2. Okay, so for the next one, what you do is you use the hypotenuse again, and the points are 2, 3, and 6, 9. Okay, 2, 3 is point C, and 6, 9 is point E. So all you do is subtract the y's for the vertical leg, which 9 minus 3 equals 6. And then to find the horizontal leg, you subtract the x's. 6 minus 2 equals 4, because x goes horizontally, y goes vertically. Okay, but you have to have the endpoints if you're going to do it this way without seeing it on a graph. But you can use a graph to also determine the endpoints and the lengths of these. Okay, so the next example gives you the endpoints for the hypotenuse. C is at 2, 3, G is at 8, 12. In order to find the length of the vertical leg, you take 12 minus 3, which equals 9. And then for the horizontal leg, you subtract the x's, and that's 8 minus 2 is equal to 6. Okay, then down at the bottom, it says a new right triangle with a hypotenuse that lies on the same line is added to this graph. The coordinates of the endpoints of the hypotenuse are x1, y1, and x2, y2. How could you determine the ratio of the length of the vertical leg to the length of the horizontal leg in this triangle? So all that means is that you're finding the slope. And here is the formula right here. So determining the ratio is like a division problem. Sometimes it can look like, for example, x ratio y, x is to y, or it looks x over y. Okay, that's just what I mean by ratio. I'm just explaining ratio right there. So the ratio of the length of the vertical leg, that's my y's, and the length of the horizontal leg. Okay, so that's the ratio, and that's how you can determine the length, because you are determining the lengths here, so you're just putting it in a formula position. Okay, I hope this kind of helps make sense. I will go to the homework page and do a couple of problems there, and hopefully that will help.